Hello and welcome back if you're following along this series where I make a 2D top-down horror shooter. And without further ado, let's continue. Last week we made our character move around, collide with walls, face the cursor, and have the camera follow our player. This week we're going to add our first game mechanic to the game, and that is 2D shadow casting. To start calculating the 2D shadow cast, we're going to have our wall calculate a few variables for us that will help us draw our 2D shadow cast. And I'm going to create a script called wall and open Visual Studio. So what we want our wall to calculate is we need to find the center, and we're going to need to know the left, top, right, and bottom of our wall. And we're going to find these using its box collider. And we'll just find these in the start method. First, we're going to get our box collider. And to find our center, we're going to take our transform position X and add box collider bounds extents X, and our center Y is going to equal our transform position Y minus box collider bounds extents Y. So what we're doing here is when we go to Unity and we have our wall, our position is up in the top left corner. So what we're doing is we're taking the extents, which is half the size, so that's 16, and adding it to our X, which will bring us over 16 pixels. Then we're going to take our Y, which is the extent of the Y's, which is 16, and we're going to subtract it from our Y position, which will bring us down. And our bounds takes into account scaling, so our scale is 10. So instead of subtracting by 16, we're going to subtract by 160, and that will give us the center right here where this gizmo is at. Okay, next we are going to find our left, which is transform position X, and our top, transform position Y, because our pivot is in the top left. And our right will equal transform position X plus box collider bounds size X, and that's the full width. And the bottom will equal the transform position Y minus the box collider bounds size Y, and that's a full width taken into account the scaling. Now we're going to want these variables to be accessed by other scripts, so we're going to have to make it public. And since it's public, it'll show up in the Unity editor, and we can hide that by saying hide in inspector attribute. This way our editor inspector is going to be clean. Okay, now we're going to save our work. We're going to go over to Unity, and we're going to grab our wall, and we are going to drag our wall script onto our wall. So next, in order to draw our shadow cast, we're going to open up our game camera script. And in our game camera script, we are going to create a new function. And we're going to call it draw shadow. And this will take two coordinates. We'll have x1, y1, x2, and y2. So before we begin, this draw shadow method is going to be drawing to the camera after it's already rendered its image. And when we're drawing in camera space, 0, 0 is the bottom left of the screen, and 1, 1 is the top right of the screen. And with that, we know that our character is at the center of the screen at all times, so we can easily just say our player X is 0.5 and our player Y is 0.5. And this F just lets the compiler know that this is a floating point number. Next, we're going to need an integer to hold our projection length, which will be the length at which we're going to multiply our coordinates out to project the shadows. Now, in order to visualize what we have here, we're going to go over to our figure. And what we have is we have our XY of our player, X1 and Y1, which represent the corner, and our X2 and Y2, which represent the edges. And for simplicity, we're going to imagine that our player is in the bottom left of our wall. Now what we can do is we can find the top left corner by using the X1 of the corner and the Y2 of the edge, and then we can find the bottom right corner by using the X2 of the edge and Y1 of the corner. Next, what we want to do is project the two furthest corners out. And we do this by finding the distance between X2 and X. And then what we're going to do is we're going to start at X2 with the distance times the projected length to project this X2 out. And we'll do the same for the Y-axis. So let's go over to Visual Studio. And we'll find our first projected coordinate. Our first projected X will equal our X2 plus the distance times projected length. And our first projected Y will equal Y1 plus the distance times the projected length. And for our other corner, we're going to project that out. Will be projected X2, and that will equal X1 plus the distance times projected length. And projected Y2 will equal Y2 plus the distance times projected length. So now to visually see what we have, we'll go to our figure. We have our three corners. We have our two projected corners. And with those two projected corners, we can make a sixth coordinate, projected X2 and projected Y1. And with these six coordinates, what we're going to do is make 4 triangles. So let's go to Visual Studio. And the first thing we want to do is use our graphics library functions. We'll say GL begin, GL triangles. And what this tells the graphics library is that we're about to be drawing triangles. So that means the graphics library will be looking for every 3 vertices that we hand to the graphics library will make a triangle. And we also want to tell the graphics library to draw with black. So the first triangle that we want to draw is going to be x1, y1 to x2, y1 to projected x1 and projected y1. So we're going to say GL vertex new vector 3. We're going to say x1, y1, 0. And we're going to copy this 2 more times. x2, y1, projected x1, and projected y1. The next triangle we want to draw is going to be x1, y1, projected x1, projected y1, and projected x2, projected y1. Let's come back to Visual Studio, and let's draw that triangle. So we already have projected x1 and projected y1. What we want to do is projected x2 and projected y1. And the next triangle we want to draw is going to be x1, y1 to x1, y2, and projected x2 and projected y2. Say x1, y2, projected x2 and projected y2. And we'll copy that. And the next triangle we want to draw is from x1, y1, projected x2, projected y2, and projected x2 and projected y1. And finally, we have to tell the graphics library to end. And that completes our draw shadow function. Now in order to draw our shadow, we're going to use the camera's on-post render method. And with this method, we can draw things to the camera image before the camera image gets drawn to the screen. Now before we start drawing all these shadows, we actually want to only draw the shadows that are within our view. So this wall currently is within our camera, so we want to draw shadows for this wall. But if there's a wall outside of our view, we don't want to draw shadows for that wall. And this is for performance reasons. So back to Visual Studio. In order to find what walls are in our view, we're going to need to know what our top left and bottom right coordinates in world space for our camera is. And in order to find those, we're going to need to know our camera width and our camera height. So first what we're going to do is we're going to have a cam height and a cam width. And we need to grab the camera that we're currently working with and call that cam. Cam will equal camera.main, which is the camera we're working with, and cam height will equal 2 times the cam.orthographic size, and the cam width will equal the cam height times the cam's aspect ratio. Now that we have our camera width and height, we're going to come down to post render, and we are going to calculate where the camera left in world position is, and that'll be equal to our transform position x minus our cam width divided by 2. And we'll calculate our camera bottom, which is equal to our transform position y minus cam height divided by 2. And what we're going to be using these for is to convert our wall coordinates into camera screen coordinates. Now to begin drawing, we are going to call our graphics library and call push matrix, which will save our current camera settings. And in order to draw, we're going to need a material to draw with. So in order to plug a material into our camera, we're going to have a serialized field called material, and we'll call that GL draw. And we'll just save our work and come over to Unity. And we click on our camera. Here we have a GL draw, and there's no material. So what we'll do is we will create a new material, call this GL draw. And for the shader, we're going to be using the sprite's default shader. And we'll go to our camera and we'll just drag our GL draw into our GL draw slot. And let's go back to Unity and go back down to our post render, and we'll just say GL draw set pass 0. And then next we're going to tell our graphics library to load ortho. And now we can begin drawing. First, we want to get all the walls in our camera view, and we'll do this by making a Collider 2D array called collisions. And that will be filled by our physics 2D overlap box all function. And the point that we're going to be using is our transform position of our camera. And the size of this box is going to be a new vector2. It'll be cam width and cam height. The angle of this box will be 0, and the layer mask is going to be the wall layer. Now what we'll do is for each collision in collisions, if any, we are going to get our wall script from our wall object. And we're going to use these coordinates to draw with. And remember, in camera space, the bottom left is 0, 0, and the top right is 1, 1. And all of our wall coordinates are currently in world space. So we're going to use these variables we made up here to convert our wall's coordinates into camera space. So we'll make a local variable left, and that will equal our wall left minus camera left divided by cam width, and our top will equal our wall top minus camera bottom divided by cam height, and our right will equal wall right minus camera left divided by cam width, and our bottom will equal wall bottom minus camera bottom divided by cam height. Now that we have our camera coordinates, we can begin using our draw shadow function. And let's go over to our figure here. Now if our player is in the bottom left of the wall, then our corner is going to be the bottom left, and the edges will be the right top. So if player transform position x is less than equal to the wall center x, and player transform position y is less than equal to the wall center y, then we will draw shadow. Our corner will be the left bottom, and our edges will be the right top. And we're going to do this for each corner. So if our character is in the top right, our corner will be the top left, our corner will be the top left, and our edges will be the right bottom. So left, top, top, bottom. And if we are on the right, top, the edges will be the left bottom. And if we're in the bottom right, the edges will be the top and left. Now, once we're all done with our drawing, we're going to call our graphics library Pop Matrix, which will bring back the saved camera settings. And we're going to save our work and go back to Unity. Now let's give this a test. And there you have it. We have our wall and it's casting shadows. So now I'm just going to create a small demo level to demonstrate how this mechanic works good in a horror game. So I'm going to create a prefab for my wall and just give it 1:1 in the prefab. And back out here, I'll make this wall 10. And I'll duplicate this wall. And duplicate it again. Make this one 20. Not 220. And I will duplicate that again. I will duplicate this wall. And we'll give it like a 7. So we have like a little doorway right here. Alright, now let's save our work. And let's test this out. So here you can see that our shadow casting mechanic is acting like our player's visibility since it's a completely solid black. And what this does is it prevents our player from looking around corners. And this is great for horror games because it will have your game keep the element of surprise. And that's all for this part in making the 2D top-down horror shooter. If you'd like to follow or double along, don't forget to subscribe. See you next time.